Hi, welcome to the first video on compiler writing help. There's a series of videos that help you write a little compiler. I'm going to use as an example language something I guess I'll call Cot as a mini version of Kotlin, so a little short form of Kotlin. So we'll start off with a language that has, well, start off in our language, I should say, with variable declarations, function declarations, while statements, print statements, break statements, assignments. So that's what we'll have here. So I'm going to use the Ohm Editor. I'm going to save a little example program in here, and then we'll try and build a grammar for our language Cot that takes care of all these things. Let's start off with dealing with our keywords and identifiers. In this language, identifiers are going to be made up of identifier characters, and we want them to start with a letter. In Ohm, letter is built in, but ID char is not. So let's define an identifier character as being any letter or digit or underscore. All right, so what we have here is identifiers or sequence one or more identifier characters. They must begin with a letter, but we also don't want them to be keywords. So let's say that identifiers are not allowed to be keywords. And what kind of keywords does this language have? So looking at our little example that we have down here, we can see let, fun, while, break, and print. So let, fun, while, break, and print. Let's go with those. And each keyword, we got to be careful because we want the keyword let to be, let, and then not have a letter or identifier character after it. We don't want to be we don't want lets to be a keyword. So we have to go and make each of these keywords not be followed by a identifier character. So let's drop those things in here. So we have let will be let, not followed by identifier character, did it with while. This prevents keywords from being picked up when there's another letter or digit after them. Okay, let's make a little bit more space. Our language should also have in it numbers or numerals, we should say. So if we just wanted integers, it would be a sequence of one or more digits. But, in general, we want a little bit more than that. We would like to have fractional parts here. And we might even have an exponential part too. So we could have like a capital E or a small e, and followed by perhaps an optional plus or minus, optional plus or minus, followed by another sequence of digits. And that part's optional too. So yeah, numbers got to be a little bit long, but what are you gonna do? Okay, so this is pretty much the lexical grammar, although I think we do want to have in our language string literals. So something like dog. So the standard way to do string literals is to say, all right, we start off with a left quote, and then we have one or more zero more characters inside, and we close it off like so. Now, what about characters? Well, characters could be almost anything, but we don't want to have double quotes or new lines or backslashes inside. So we'll follow standard practice over here and say that characters have a couple of different forms. It's any character you want, but you don't want new lines or backslashes or double quotes in there. If you do have a backslash, it needs to be followed by a character. So we'll do a rather short form of characters like so. And this is pretty much our lexical grammar here. Now, as far as the top level view, we want our program to be a sequence of statements. So let's just start at the top with a program being one or more statements. Now, we could use it. Yeah, let's do one or more statements. That's fine. Now, what kind of statements do we have in here? Well, I see variable declarations, I see function declarations, while statements, and so on. I even see a print statement. So I pre-created a list of statements over here. So let me drop these right here and see what we got here. All right, so one form of a statement is let identifier equal sign expression. That's called a variable declaration. We have a function declaration, fun ID, and then we put in our params. And then we have the body of the function here. We have a while with a test and a body. We have a break. And then we have an assignment where we're assigning variables. The thing about some languages when they get complex is the left-hand side, sorry, of an assignment is not necessarily just an identifier. It may be something more complex. So I'm just calling these variables. And then we can do a print. If we want to be, I guess if we want to be fancy, we should probably we could put parens around our expression just to make it look more like it's might make it look like it will trick people into thinking it's a function call when it's really not. Okay, so here are several kinds of expressions. I think we have 6 kinds of statements, 6 kinds of statements: variable declaration, function declaration, while statement, break statement, assignment, and print. Right now, the Ohm editors complain that we don't have expressions defined, so let's put expressions in the mix. If we want to keep things simple at the beginning, we could say, oh, an expression is just a numeral. Okay, that's a little bit boring, but we can fix it up later. Oh, I see we're complaining here about parameters. So let's talk about parameters. In our language, in COT, parameters have the form identifier, colon, and then a type name. So let's drop that in here. Parameters will be a list of parameters separated by commas, and each parameter is an identifier, colon, and a type. So we're going to have to define what a type is. Now, most of the time, types are simple little identifiers like int, bool, char, whatever. But we can also have types like, maybe this is a type here, integer array, or character array, or a string array, something like that, right? So in general, we can, yes, while types can be identifiers, we can also put a type followed by brackets to make an array type. So let's actually call this one an array type. And let's make some space over here. Array type. Woohoo. Okay. We don't have blocks. Blocks are a natural thing to put in here next. A block is going to be, let's look at it right here. See down here, it's just a bunch of statements with braces around them. So let's take care of that. A block is going to be 0 more statements surrounded by curly braces. So this looks good. Okay, we don't have var yet. We'll get down to var after we start making let's start doing expressions a little bit better. Now, you may remember we talked about this a little bit earlier, how expressions are made up of primary values with operators possibly between them. And the primary values, start off here with primary. Let me drop in a rule for primary. So primaries are the lowest possible levels of expressions. They can be function calls, numerals, variables, parenthesized expressions, or string literals. I'm going to put my string literals up here where they feel a bit better. Okay, and then put parentheses. These are the lowest level of expressions. Okay, now a variable, by the way, what do variables look like? Well, a variable is something like plain old x, okay? But it could also be an expression like x s0 or a sub 1. These are actually variables. So a good way to represent variables is as follows. Let me plop it in here. A variable can be an ID, right? Sorry, Ohm loves to give you all your errors and get you away. A variable can simply be an ID, like plain old x, right? Or it can be any primary expression that's not a numeral followed by square brackets. This is what's allowed, square bracketed expression, I should say. This is what allows us to make variables like a sub 1 sub 5, which we'll see if we can get that working pretty soon, or even a sub 5 times x, which is also good. So variables can be somewhat complex. That's fine. It's just that we don't want to have a number before the brackets, like that's not a variable, but this is a variable. Or a variable can be an ID. We already have num, we already have string. We don't have call. The call is just going to be something like a variable followed by parentheses, followed by a list of arguments, and arguments are expressions separated by commas. Okay. And this, I think, will satisfy as a, this will be a good call. Okay. All right. What do we have at the moment right now? Well, at the moment, it looks like our our grammar doesn't have any more errors in the grammar, but our tests don't pass because it looks like how did that sign get over there? This sign used to look like this. This used to say something like bar x equals something like that. Anyway, or no, it wasn't var, it was let. Okay, yeah, see, it doesn't, our expressions right now are just going to be numbers, and that's not good enough. We need to build up our expressions with all of our operators. So we have our primaries right here. And expressions definitely have to be more than just primaries, right? We have to build up our hierarchy of operators. And we could start at the top with the very, very lowest precedence. The very, very lowest precedence operator is often, but not necessarily, the conditional or ternary operator. So I'm going to start with that one. And the next one we're going to do is the logical operators, which are going to be our ands and ors. Well, I'm going to do or first and then and. And I'm going to make these, it doesn't really matter. I can just go ahead and make them left associative, which is fine. And so let's see how we have conditionals are the lowest level and they're right associative. And then we have at the next level, we have left associative or, and then we have a right associative, left associative and also. After and, we want to do our relational operators. So let's do relational operators next. And what do we have here? Okay, I want these to be non-associative, separated by relational operators. We'll mark the complex one with a case label like we need. Okay, we need relational operators. Fortunately, I have them pre-made. Let's drop relational operators in here, right about there. Okay. Remember, we are using ohm, so if we have less than or equal, must come before the less than. Remember, long things have to come before short things, which is also why call has to come before variables, because variables will, might start with an ID. So I want the ID here, and there's an ID there as well. Actually, I don't know if it really matters about calls. We might have to address this later when we look at some more complex forms, but I think for right now, things are looking okay. Okay, for EXP3, let's put this back in here. What's next after relational operators? Well, after relational operators, we can start moving into the classic expressions, terms, and factors. So let's do our arithmetic down here. So we're going to make the next level at EXP4 is going to be the level at which we do our left associative addition subtraction, our left associative multiplication, division, and remainder. And then we can drop in the exponentiation down here as a right associative operator. And clean up our grammar a little bit. And how we doing? We still have an error down here somewhere. It doesn't like, oh, you know what I think happened over here? I think somehow I dragged some text over here. Okay, expected parentheses. Yeah, I decided I wanted to change my print to require parentheses. And there you have it. Our test case is now green, and we have a grammar for our tiny little language called COT. So this was a short exercise in designing up the language. Yes, the language does not have fancy string literals. It doesn't have interpolation. It doesn't have classes or modules or optionals or anything like that. But we're just getting started with a rather simple compiler. So we'll leave it at that. Okay, thanks for watching.